everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics, Chapter 11, Calorimetry. We have already started this chapter. I have given you an introduction to calorimetry. Today, we will be discussing the topic change of state and latent heat. Are you all ready for today's class? Let's start. States of matter. We have been studying states of matter from the class 3rd. Okay, we have studied 3 important states of matter. What are they? Solid, liquid and gas. What is the difference between them? We know that all these are made up of, all these substances are made up of atoms and molecules. Here in case of solids, you can see that all the molecules are held close together. Okay, they are tightly packed. When you take the case of liquids, the molecules are loosely packed, and in the case of a gas, they are freely packed. That is, they are freely moving. You can see there is more interatomic or intermolecular spaces between them. So this is a basic difference between solid, liquid and gas. Can you give me some examples for solids? When you take the case of wood, wood is a solid. Okay. Then plastic, plastic is a solid. Ice is a solid. What about liquid? Examples for liquid. Water is a liquid. Milk is a liquid. Okay. Milk is a liquid. Then when you take a gas, carbon dioxide is a gas. Hydrogen is a gas. Hydrogen gas. Okay. So we have examples. Now you know that when you take the case of water, water can exist in all the 3 states. That is, water can exist as solid in the form of ice. Okay. The normal water is a liquid. In the gaseous state, you have vapor. So what is happening? When you take ice, this ice melts to form water, and again when the water is boiled, you get water vapor. Okay. In all these 3 states they are existing. That is, when you take water and freeze it, okay, at 0 degrees Celsius, you will be getting ice. Okay. Same water when you are boiling at 100 degrees Celsius, you will be getting vapors. Okay. So this water, which exists in 2 different forms, 3 other forms, that is, all the 3 forms this water is existing. So we can say that from one state to another state, you can make a change. That is, this solid can be converted to liquid, liquid can be converted to gas. Okay. So states of matter can be changed. You understood what state of matter is? Change of phase or change of state. When we have taken the example of water, we had ice, water and vapor. Okay. Now here, when you take a water and keep it inside the freezer of a fridge, what happens? It gets changed from this water liquid state to a solid state. Okay. That is, when you cool the water, that is, you are reducing the temperature, it reaches 0 degrees Celsius. What happens is, at this temperature, water slowly gets converted to ice. Okay, the temperature will be the same. Temperature will be 0 degrees Celsius. Water will get completely converted to ice. Okay. Similarly, when you take this water and you are heating water or boiling water, what happens is, when the temperature reaches 100 degrees Celsius, all these water gets converted to vapor. Until it gets completely converted to vapor, the temperature will be the same, 100 degrees Celsius. The heat energy is getting used to convert water to vapor. So we understand that there is a heat exchange. Okay, there is a heat exchange happening in these cases. Also, the temperature will be remaining same when there is a exchange. That is, when there is a transfer or when there is a change in state. So we can define the change of phase as a process of change from one state to another at constant temperature. At constant temperature. Here 0 degrees Celsius to convert water to ice. At 100 degrees Celsius, water is getting converted to vapor. And this is called change of phase. So when you take the solid, liquid, gaseous state. Solid, liquid, gaseous state. So to convert solid to liquid, what you are doing is you are melting the solid. Okay. Now liquid to gas. This process is called vaporization. Okay, now the reverse process to convert gas to liquid. Gas to liquid conversion is condensation. Condensation. Liquid to solid. Liquid to solid, that is water to ice. What we are doing? We are freezing. Freezing. Next, if you are converting solid directly to gas. Solid to gas conversion. This process is called sublimation. Okay, we'll be explaining in detail. This is sublimation. And from gas to solid, directly from gas to solid without the existence of liquid state, it is called solidification, or also it is known as deposition. Okay, we'll understand them in detail. So got it? So here you can understand how different states are changing to the other forms by different process. Okay, temperature will be the same. Melting and freezing. Let's take a simple example. When you take ice cube and keep it on floor for some time, what happens? It gets completely converted to water. Or you're taking some ice cubes in a glass. What happens? After some times, it becomes water. So, converting ice to water, this process is called melting. During this process, heat energy is absorbed. That is, when you have ice at 0 degrees Celsius and you have to convert it into water at 0 degrees Celsius, you will be absorbing heat. Okay, there is absorption of heat. And this process is called melting. Okay, now the reverse conversion. You have to convert water to ice. In that case, 0 degrees Celsius water to 0 degrees Celsius ice, there is a liberation of heat. Okay, what can be done? You can take water, and this water, when it is kept in freezer, it gets converted to ice. Heat energy is given out. There is liberation of heat, and this process is called freezing. Okay, temperature will remain the same. Here, heat energy, exchange of heat energy or absorption of heat and liberation of heat is happening. Okay, when you have a given mass of substance, the heat energy that is absorbed to convert it from solid to liquid state will be equal to the heat energy that is liberated while converting it from water to, or the liquid to solid state. So, you can define melting as the change from solid to liquid phase by absorption of heat. Okay, by absorption of heat, changing solid to liquid. And freezing is a change from liquid to solid phase with the liberation of heat. Clear? Understood what melting and freezing is? Vaporization and condensation. We have studied about water cycle. So, what happens is, during a sunny day, water gets evaporated. Okay, evaporated, and then when it reaches the sky, there condensation happens. Okay, so we'll understand what condensation and evaporation is. Evaporation and vaporization. Evaporation, when it comes to the case of only water, we say evaporation. Vaporization is the normal term, that is a liquid getting converted to vapor is what vaporization is. Again, the temperature will remain the same. The change from liquid to vapor phase is called vaporization, and the change from vapor to liquid phase is called condensation or liquefaction. Okay, that is the clouds formed, and here the clouds are formed, after which it is getting converted back to liquid. The gaseous state is getting converted to back to liquid, and we get rain. Okay, understood? So here you have a vaporizer. Why is the vaporizer used? When you get fever or cold, you use this vaporizer. So here you are adding water to this. Okay, closing the lid. When current starts flowing, you will be getting vapor. It is the water is getting heated. Okay, and you will be start to get vapor. So here the process is vaporization. The liquid is getting converted to steam. The liquid is getting converted to vapors. Okay, sublimation and solidification. Sublimation is the process where solid is getting directly converted to gaseous state. Okay, for example, you have familiar examples. One is camphor. Have you ever seen the liquid form of camphor? No, right? So this camphor, it is getting directly converted to its gaseous form. Then naphthalene balls. Naphthalene balls, when you keep it inside a room or inside a shelf, after some days you won't be able to see this naphthalene ball. What has happened? This solid state of naphthalene ball gets converted to gaseous form. Then you have dry ice. Dry ice is carbon dioxide at a very low temperature, or the solid state of carbon dioxide is dry ice. Okay, also providing a sufficient temperature, what happens? That is at very low temperature, 0 degrees Celsius, carbon dioxide exists as dry ice. Okay, when the temperature changes, temperature increases, what happens? It gets converted to carbon dioxide directly. Here again, there is a change from solid to gaseous state directly without going to the liquid state. Okay, understood what is sublimation? Now the reverse process, that is converting gas to a solid, is called solidification, or it is also known as deposition. One example is ice rain. Okay, here in case the clouds gets converted, the vapor form is getting converted to directly to the solid. So in this form, you will be getting the rain. Okay, you have observed anywhere? So you might have seen these forms of strong ice pieces, you can see as rain. Clear? We understood what melting and freezing is. Now what is melting point and freezing point? As we have said, at 0 degrees Celsius, what happens? At 0 degrees Celsius, ice gets converted to water. Okay, this is melting. Okay, at this particular temperature, temperature does not change unless all these ice gets converted to water. The temperature will remain the same, and this temperature is 0 degrees Celsius. This temperature is called the melting point. Okay, then what is freezing point? For the reverse process, as we have said, at 0 degrees Celsius, you can convert water to ice. Okay, when you keep the water in fridge, when it reaches 0 degrees Celsius, all the water gets converted to ice. The temperature will remain the same. So, ice gets converted to water at 0 degrees Celsius. Water gets converted to ice at 0 degrees Celsius. This temperature, ice conversion to water at 0 degrees Celsius, this temperature is the melting point, and this temperature is the freezing point. The constant temperature at which a solid changes to liquid is called melting point of the solid. The constant temperature at which liquid freezes to solid is called freezing point. Okay, so when you take a pure substance, its melting point and freezing point will always be identical. You will have the same value. For example, when you take this case, the melting point and the freezing point will be the same value. Heat curve of ice during melting. So for this, you have to perform an experiment. Take a test tube, fill the test tube, half the test tube with ice cubes. Okay, then you have to keep a thermometer. Remember, the bulb of the thermometer should not touch the walls of the beaker. Okay, when you keep a thermometer, why is the thermometer used? To measure the temperature. When you keep a thermometer in this ice, you can note that the temperature will be 0 degrees Celsius. Okay, initially the temperature is 0 degrees Celsius. Okay, now what you're going to do is you're going to provide heat. Okay, you have to start heating this. While heating means what is happening? You are giving heat energy. Heat energy is being supplied. Okay, every 30 seconds. Okay, every 30 seconds, you're going to note the temperature. Okay, initially we have said that temperature is 0 degrees Celsius. After 30 seconds when you note, it will be again 0 degrees Celsius. So heating means what is happening? The ice will start melting. Okay, it will start melting. Next, after 60 seconds when you check, again the temperature is 0 degrees Celsius. Next, again 30 seconds, 90 seconds you are going to check, it is 0 degrees Celsius. At 120 seconds when you check, again it is 0 degrees Celsius. At 150 when you check, there is a change in temperature. Let's say some 10 degrees Celsius is the temperature now. Here what has happened? Till 120 seconds, the temperature remains the same even though the time has changed. That is, heat energy is taken, but still the temperature was constant. The temperature was 0 degrees Celsius. So here a graph was plotted between time in seconds and temperature in degrees Celsius. So this is how the graph looked like. Okay. Here what has happened is the heat energy that we have supplied is used to convert ice to water. Until all the ice gets converted to water, there is no change in temperature. Once you get water, okay, once you get water, that is the ice has completely melted to form water. Now what happens? The heat energy which is being provided will be used to rise the temperature. So this is what is happening. So here what happens? At 120, the temperature is 0 degrees Celsius. But when it becomes 150, it has changed to some 10 degrees Celsius. At 180, it has changed to some 20 degrees Celsius. At 210, it has changed to 30 degrees Celsius. So here, the temperature is changing. So here you have two parts of the graph. One is the region AB. In this region, what is happening? Ice is melting to form water. The process of melting is happening. During that time, temperature will remain the same even though the heat energy is being supplied. Okay, after that till BC, in the region BC, what is happening? There is a rise in temperature. All the ice has got completely converted to water. Only then there is a rise in temperature. Clear? So this is the heat curve of ice during the melting process. Change in volume on melting. That is, when you take some substance, what happens is when you supply heat, that is, it starts melting, the substance volume will increase. Okay, that is, the substance will expand. But in some cases, what happens is it will contract, the substance will contract, that is, the volume will decrease. So for most of the substances like lead, wax, etc., when you take these cases, they expand on melting, but for some substances like ice, they contract on melting. You have heard of lead. So this is lead wire. This lead wire, it is used for soldering purpose, and you bring a solder iron close to this lead wire. What happens is, due to the heating, the solder iron, due to the heating, what happens is this lead wire will start to melt. Okay, when it melts, what happens? It is expanding, that is, the volume is increasing. Okay, lead is an example where the volume is increasing on melting. Then when you take the case of wax, here again, when it melts, its volume will increase. For example, let's say you are taking solid wax. Okay, 1.161 centimeter cube of solid wax is taken at a temperature 64 degrees Celsius. So what happens? Here melting happens and it forms molten wax. Now the volume will become 1.166 centimeter cube. So when you check these values, you will understand that the volume has, what happens to the volume? The volume has increased. Centimeter cube is the unit of volume. The volume has increased. Now when you take the case of ice, let's say if you are taking some 1.091 centimeter cube of ice at 0 degrees Celsius, what happens? It starts melting and it will be forming water. Okay, it will form 1 centimeter cube of water. Here what happens? The volume has decreased. Okay, in case of ice, the volume has decreased. So, in some substance, the volume will increase, and in some substance, the volume will decrease on melting. Okay. Effect of pressure on the melting point. Melting point of some substances which contract on melting, like ice, decreases with increase in pressure. When you take the case of ice, we know that in ice, when the melting process happens, what happens? The substance is contracting, the volume is decreasing. So here, when you increase the pressure, the melting point will be decreasing, which means melting point is inversely proportional to pressure. When one quantity increases, the other quantity should decrease. Pressure increases, melting point decreases, pressure decreases, melting point increases. For example, if you are making a change, that is, if you are increasing the pressure by 1 atm, atm is a unit of pressure, then bar, pascal, etc. are the units. So if you are increasing the pressure by 1 atm, then the melting point will be decreasing by 0.0072 degrees Celsius. So here, this much decrease in temperature happens to ice when 1 atm pressure is increased. Okay, when pressure is increased by 1 atm. Clear? Okay. Now, the melting point of substances such as wax, lead, etc. These are substances which expand where the volume increases on melting. Which expands on melting, increases by increasing pressure. In these cases, they are directly proportional. Melting point is directly proportional to pressure, which means when pressure increases, melting point increases, pressure decreases, melting point decreases. Okay. Effect of impurities on the melting point. The melting point of a substance decreases by the presence of impurities in it. Impurity, for example, when you take the case of salt, salt is an impurity. On adding salt while making of ice, what happens is the temperature, that is the melting point, it decreases from 0 degrees Celsius. We know that melting point of ice is 0 degrees Celsius. It reduces to minus 22 degrees Celsius. Okay, that is salt is added in a particular proportion to ice. Then what happens? From 0 degrees Celsius, which is a normal melting point, it decreases to minus 22 degrees Celsius. Okay, so for the freezing purpose and all, it is very helpful in making kulfis. Adding impurity, it will be very helpful because on adding impurity, what happens? The presence of impurity is going to decrease the melting point. We can decrease the melting point. The ice won't get melt easily. Okay. Vaporization and boiling. When you take the case of boiling, you know how to boil water. If you take water and you start heating it, only at a particular temperature, you will be able to see these bubbles. Okay, when you start seeing these bubbles, we say that the water has started to boil. Okay, so here vaporization is a process where at a given temperature, at a constant temperature, what is happening? The water, the liquid is getting converted into the gaseous form. Okay, liquid conversion to gaseous form. This is called vaporization. The change from liquid to gas or vapor phase on absorption of heat. You are supplying heat, absorption of heat at a constant temperature. The temperature should remain constant. Is called vaporization. Understood? So vaporization will be happening at a particular temperature, which is called its boiling point. Now you have to remember, while heating, what happens is the temperature when it becomes 100 degrees Celsius, only then at this temperature the conversion of water to vapor will happen. Okay, water will be getting converted into water vapor. So during this conversion, that is until all the water gets converted into vapor, the temperature will not increase anymore. That is, temperature will be remaining 100 degrees Celsius only. This temperature at which this boiling process or vaporization process happens is called the boiling point. The particular temperature at which vaporization occurs is called boiling point of liquid. Also, you can define boiling point another way. We know that the atmospheric pressure and the vapor pressure, here a pressure will be developed due to this boiling process. All the vapors, all the molecules will be experiencing a pressure. This pressure is called vapor pressure. When this vapor pressure will become equal to the atmospheric pressure, this temperature can also be called the boiling point. Boiling point is the temperature at which vapor pressure of liquid becomes equal to the atmospheric pressure. Okay, when vapor pressure and atmospheric pressure, at vapor pressure of the liquid and the atmospheric pressure becomes equal, at that temperature, boiling will be happening, and this point is called the boiling point. Next is the reverse process of vaporization, which is condensation. In vaporization, water is getting or liquid is getting converted to the vapor phase or the gaseous phase. Here what happens is the vapor gets converted into the liquid phase. That is, from clouds we are getting rain. Rain is in the liquid state. Okay, the water is in the liquid phase. The change from vapor to liquid phase or liberation of heat. In case of vaporization, we had absorption of heat. When it comes to the case of condensation, which is just the opposite process, there is a liberation of heat at a constant temperature. At a constant temperature. Again, temperature should remain constant when all the vapors gets converted to the liquid phase. It is called a condensation, or it is called the liquefaction. Another name is liquefaction. Okay. Now, if you are taking 100 degrees Celsius water, okay, 100 degrees Celsius water, this water absorbs heat. Okay, there is absorption of heat. On absorbing heat, what happens? The process is boiling. Boiling takes place, and all these 100 degrees Celsius water molecules gets converted into 100 degrees Celsius steam. Temperature will remain the same. Okay, so all these water molecules will get converted into 100 degrees Celsius steam or vapors. Okay, now the reverse process. During the process of condensation, there is liberation of heat. Heat is given out. Liberation of heat. Liberation of heat. Okay, then the process is called condensation or liquefaction. So when you take the case of pure substance, as we have said, the melting point and the freezing point will be the same. Okay, it will be a constant value for a given substance. Similarly, when you take the case of a pure substance, the condensation point and the boiling point will be the same, which is 100 degrees Celsius for water. Okay. Now, heat energy that is absorbed at a constant temperature during vaporization, while the same amount of heat energy is liberated during condensation at that temperature for a given mass of substance. Heat energy which is absorbed at a constant temperature during vaporization. During vaporization process, we have said that heat energy is absorbed. During condensation process, heat energy is given out. Okay, so these two, that is the heat energy absorbed and the heat energy liberated at a constant temperature, will be same when you take the case of a given mass of a substance. Okay, for a given mass of substance, this heat energy that is absorbed during vaporization and the heat energy liberated during condensation will be the same. Okay. heating curve for water. We'll perform an experiment to understand this. You have to take water in a given flask or some beaker something. So you have to suspend, that is you have to put a thermometer in it. Remember, the bulb of the thermometer should not touch the walls of the flask. Okay, then using a Bunsen burner, heat energy is being supplied. When heat energy is being supplied, what happens? The water starts heating. It will start boiling. So a graph is plotted in the similar manner which we had done before. A graph is plotted between the time on the x-axis and temperature on y-axis. So here the temperature is increasing. You are taking water which is at a room temperature, that is, let's say 20 degrees Celsius. We are taking water at 20 degrees Celsius. Okay. For every half minute, that is 30 seconds, you are noting the values. Every 30 seconds, you are noting the values. 30 second, 60 second, 90 second, 120 second, 150 second, etc. Okay. So here you can see at first, initially at 0 time, that is initially when you are starting the experiment, you can see that the temperature of the water is 20 degrees Celsius. You can get the reading on the thermometer. You will be getting at the starting, you will be having 20 degrees Celsius temperature. Let's say at 30 seconds, when you see 30 seconds, it is somewhat 80. The temperature has changed to 80 degrees Celsius. Okay. Next, when you are checking at 60 degrees Celsius, at 60 seconds, you can see that the temperature has become 100 degrees Celsius. Then again 90, when you check, you can see that the temperature is 100 degrees Celsius. Again at 120, it is 100 degrees Celsius. Again at 150, it is 100 degrees Celsius. So here you can see, when you plot the graph, you can see that initially at the starting, the temperature was 20 degrees Celsius. Here it is increasing. The temperature is increasing with change in time. But what happens suddenly when at a particular time, you will be getting a temperature 100 degrees Celsius. After that, what is happening? Time is increasing. Okay, we are performing the experiment. You are noting the temperatures. The temperature is not changing. So what is happening to the heat energy that is being supplied? There is no change in temperature. We are supplying heat energy, but still continuous supplying of heat energy, there is no change in temperature. So where is this heat going? Here this heat is being used to convert water into vapor. Water is changing into water vapor. Okay, till all the water. So when you note this, you can see that during the boiling, you can see bubbles. Okay, that is the water is getting converted into vapor. On the walls of this beaker, you can be seeing that bubbles will be formed. Okay, vapors will be formed. Until all this water gets converted to vapors, the temperature will remain 100 degrees Celsius only. Okay, there won't be any rise in temperature. That's why you are getting a plot such that, a graph is such that you are getting a straight line. So till here there is a rise in temperature. When you reach B, when you reach the point B, what is happening? There is no increase. Okay, that is you are getting a line that is parallel to the time axis, parallel to the x-axis. So this point B is the boiling point. So when water reaches this point, after that, the heat energy is being used to convert the water molecules into vapor. Okay, there is no more increase in temperature until all the water gets converted into vapor. After that, there will be an increase in temperature of the vapors. Okay, until after all the water molecule has been converted into vapor. So clear? So this is it. AB is the region where there is increase in temperature with increase in time. Okay, and BC is the region where the complete conversion of water to vapor is happening, and D is the point where the boiling starts, and this point is the boiling point. Okay, change in volume on boiling. On melting, we have said that in case of some substances, what is happening? The volume is increasing, the substance is expanding. But in some cases, what happens? The volume is decreasing. In case of ice, the volume is decreasing. That is there is contraction. Okay, so now when you take the case of boiling, here all liquids will expand on boiling. There is no exception. All liquids will expand on boiling. For example, if you are taking 1 centimeter cube of water at temperature 100 degrees Celsius, it will be boiling. Then it will get converted into steam of volume. The volume will be 1760 centimeter cube. So here we have understood that the volume has increased. There is expansion happening. It is not just the case of water. Any liquid, if it is boiled, what happens? There will be a increase in volume. There is always an expansion. Effect of pressure on the boiling point. The boiling point of liquid will increase with increase in pressure and decrease with decrease in pressure. We know that at 1 atm for pure water, when you take the case of pure water, the boiling point is 100 degrees Celsius at 1 atm. This is atmospheric pressure, or 760 millimeter of mercury. Okay, this is a normal atmospheric pressure. Here, you will be taking two cases. The first case is in the case of a pressure cooker. In case of pressure cooker, we can see that the vapors are not allowed out. Okay, that is, the vapors are staying inside. Due to this reason, here what happens is the pressure is increasing inside the pressure cooker. The pressure is increasing. The molecules are experiencing more pressure. It is about 1.75 times the atmospheric pressure. The pressure inside a pressure cooker, the molecules experiencing the pressure will be 1.75 times the atmospheric pressure. Here the vapor pressure is increasing. Vapor pressure is more than the atmospheric pressure. So now what happens is, due to this reason, the vegetables and all get cooked easily, because it is here the boiling point is increasing. Okay, the boiling point is increasing. Normal boiling point we know is 100 degrees Celsius. Okay, here the boiling point of water, it becomes some 120 degrees Celsius to 125 degrees Celsius. So water will boil only at this temperature. So more heat energy is given. So this heat energy will be used by the vegetables to get cooked easily, and the vegetables can stay hotter for a longer period of time. Now the second case is cooking at high altitudes. At high altitudes, what happens is the atmospheric pressure will be low. Okay, at high altitudes, atmospheric pressure will be low. So here what happens is the heat, that is the boiling point, will be less than 100 degrees Celsius. Boiling point of water will be less than 100 degrees Celsius. Okay, here we have seen that the boiling point is more than 100 degrees Celsius, 120 degrees Celsius to 125 degrees Celsius. Here it is, the boiling point is less than 100 degrees Celsius. What does it mean? The water gets boiled at a temperature less than 100 degrees Celsius. So that is, the vegetables or whatever you are cooking won't get cooked. Enough heat energy is not, the vegetables won't be getting enough heat energy. The water will start boiling easily. So here we will be recommending that you have to not cook at a open area at high altitudes, because their atmospheric pressure is low, and due to this reason the boiling point of water will be less. Water will get boiled very faster compared to that. The enough heat energy won't be available for the vegetables or whatever is there to get cooked. Effect of impurities on the boiling point. The boiling point of liquid increases with addition of impurities. You have seen that while cooking vegetables and all, we'll be adding some salt to it. Salt is an impurity. Okay, salt is the impurity that is being added to water. It is being added to water. Now what happens is, by adding salt, the boiling point, normal boiling point we know is 100 degrees Celsius. Now the boiling point will become greater than 100 degrees Celsius. Boiling point of water has changed. The boiling point of water has increased. So the heat energy will be used by the vegetables to get cooked easily. Okay, before the water boils, or what happens? If the water boils, the water will be getting converted into vapors and the cooking becomes difficult. But here, before the water reaches its boiling point or water starts boiling, the heat energy will be used by the vegetables to get cooked. Okay, so due to this reason, that's why we are adding salt to water while cooking. Next is latent heat. What is latent heat? We said that during the process of melting, solid is getting converted into liquid during melting. Okay, we know that this happens at a constant temperature. Heat energy is getting absorbed in this case. When liquid is getting converted to solid, that is during the freezing process, what is happening? There is liberation of heat. There is a particular amount of heat that is absorbed in the first case, and there is a particular amount of heat that is liberated in the second case. For pure substance, we have said that this amount of heat will be the same. Okay, now if the liquid is getting converted to vapor, by the process of vaporization, by the process of boiling, when liquid is getting converted to vapor, here again the temperature will remain constant. Temperature will remain 100 degrees Celsius. But what is happening? There is a heat energy absorption. Reverse process, vapor to liquid during the process of condensation. Here also what is happening? There is during the process of condensation, there is liberation of heat. Heat energy is being given out. There is a particular amount of heat. Okay, this particular amount of heat is what the latent heat is. So you can define latent heat as the amount of heat that is required to convert a solid into a liquid or vapor Either it can be solid to liquid or solid to the vapor state, or liquid into vapor at a constant temperature. The temperature should remain constant. That we have said during melting and freezing process 0 degrees Celsius. During vaporization and condensation 100 degrees Celsius. So at this particular temperature, what is happening? There is a heat energy that is absorbed. This heat energy, amount of heat energy is called the latent heat. Clear? So this is what latent heat is. There are two types of latent heat we will be discussing now. Latent heat of fusion and latent heat of vaporization. We have studied about fusion and vaporization. Now you just look at this graph. Here you can see heat energy that is being supplied is given along the x-axis and temperature is given along the y-axis. You can see that here we have a substance which is in the solid state. Heat energy is being supplied. What is happening? The temperature is increasing. Heat energy is supplied to the solid. The temperature is increasing. This region. Okay, it reaches the temperature. At this temperature, now what happens is still heat energy is being supplied, but you can see that the temperature will remain a constant. Here what happens is the solid is getting converted into liquid. Okay, that is this temperature is called the temperature. Here solid is getting converted to liquid. So here what is happening? There is a melting point. It is the melting point of the substance. And the heat energy that is being absorbed for this process is a latent heat of fusion. Okay. Temperature remains constant as solid turns to liquid. Here the complete conversion of solid to liquid is happening. Now after the conversion to liquid, again heat energy is being supplied. Till then all the solid molecules of the solid gets converted into the liquid form. Here the temperature will remain the same. Again, once all of the substance solid has been converted to liquid, on supplying heat energy further, now what happens is temperature will again increase. Temperature of the liquid has been increasing. Okay, it reaches the temperature, this temperature. Now what happens is the liquid will get completely converted to gas. It is getting completely converted to gas. Okay, here heat energy is being absorbed. This heat energy, the latent heat of vaporization. This heat energy is the latent heat of vaporization. Temperature remains constant as liquid turns to gas. Here the heat energy is being used. That is being used not to rise the temperature but to convert the liquid completely into gas. Until all the liquid gets converted to gas, the temperature will remain the same. Okay, so liquid to gaseous state. Once it reaches gaseous state, again what happens? There will be increase in temperature. Okay, temperature will be increasing when you supply heat energy. So this is latent heat of fusion and latent heat of vaporization. So you can define latent heat of fusion is the heat required to change the state of a substance from solid to a liquid at constant temperature. Temperature remaining constant, you are converting the solid to liquid completely. Okay, and latent heat of vaporization is the heat that is required to change the state of a substance from liquid to a vapor at constant temperature. Okay. Specific latent heat. Specific latent heat is when you consider a given mass of a substance. So, latent heat expressed for unit mass is specific latent heat. Specific latent heat of a phase is the quantity of heat energy absorbed or liberated by the unit mass of the substance for the change in its phase at a constant temperature. So, when you define latent heat, we didn't mention about mass. But here, when you are taking for a unit mass, for a given mass of a substance, in that case, it becomes specific latent heat. So, specific latent heat, which is represented by the letter L, it is the heat absorbed or liberated for the change of phase divided by the mass. The amount of heat energy that is liberated or absorbed divided by the mass. Okay, heat energy we are representing by letter Q and mass by M. Then L is equal to, specific latent heat L is equal to Q divided by M, or if you are asked to find the heat energy that is required, if you know the specific latent heat, we know the specific latent heat will be a constant for a given substance. Specific latent heat into the mass of the substance. When you do this, you will be getting the heat energy that is absorbed or heat energy that is liberated to convert, to make a change from solid to liquid, whatever it is. Okay. Units of specific latent heat. We know that specific latent heat L is equal to Q divided by M, where Q is heat and M is mass. So, what are the possible units of heat? Heat can be expressed in joules, it can be expressed in calories, and it can be expressed in kilocalories. Okay. What about mass? Mass can be in gram, mass can be in kilogram. Okay. Now, first the standard unit or the SI unit is joule per kilogram. Joule per kilogram is the standard unit, okay, or the SI unit. Now, other units, other possible units, when we take the heat in joules, heat energy in joules and mass in grams. So, this is a possible unit, joule per gram. When you take heat in calories and mass in kilograms, this is a possible unit, calorie per kilogram or calorie per gram. When you take mass in grams, kilocalorie per kilogram or kilocalorie per gram. So, all these are possible units. Now, the interconversion, we know that 1 calorie is equal to 4.2 joules. Okay. So, first 1 kilocalorie per kilogram will be equal to 1 calorie per gram. Why? Because 1 kilocalorie by kilogram or per kilogram, it will be equal to 1 kilocalorie is 1000 calories. Okay, and 1 kilogram is 1000 grams. So, this can be cancelled and that will be equal to 1 calorie per gram. Next, 1 calorie per gram. 1 calorie per gram will be equal to, 1 calorie we know is equal to 4.2 joules. Okay, per gram. Now, the third, 1 calorie per gram. 1 calorie per gram will be equal to, 1 calorie is 4.2 joules per gram. We are changing to kilogram. If 1 kilogram is 1000 grams, then we have to convert gram to kilogram. 1 gram will be equal to 1 by 1000 kilogram, or that is equal to 1 by 10 raised to 3 kilogram or 10 raised to minus 3 kilogram. Okay, so here you will be getting 10 raised to minus 3 kilogram. Now this will be equal to 4.2. Here 10 raised to minus 3 is in the denominator. Taking to numerator, it becomes 10 raised to 3 joule per kilogram. So this is the interconversion. Just you have to know the relation, that is, what is the relation between kilocalorie and calorie, what is the relation between calorie and joules, what is the relation between kilogram and grams, then you can make the interconversions and the different units. So in problems, if they are asking in whichever unit is given, you will have to check in which unit you have the mass, in which unit you have the heat, in which unit the specific latent heat is given. So accordingly, you have to take. Let us take an example. How much heat energy is required to melt 5 kg of ice? Specific latent heat of ice is 336 joule per gram. Here mass is given. Mass is equal to 5 kg. Now remember, mass is in kilogram and the unit is joule per gram, which means you have to convert this kilogram to grams. 5 kilogram will be 5000 grams. What about the latent heat? Latent heat L is given. Latent heat L is equal to 336 joule per gram. Now, how to find the heat? Heat will be equal to mass into latent heat. Here the mass is 5000 into 336, that is equal to 336 into 5, you will be getting 1680 and you will be having 3 zeros. Or you can write this as 1.68 into 10 raised to 1, 2, 3, 4, 5, 6, 6. Okay. Now heat, what is the unit of heat? Unit of heat is joules. So this is the heat energy that is required to melt 5 kg of ice with the latent heat of ice given. Okay. 1.68 into 10 raised to 6 joules. Specific latent heat of fusion of ice. In case of ice, if you are considering ice will change to water. Okay. So here for ice to change to water, we know the temperature will be 0 degrees Celsius and the amount of heat energy that is required to change ice to water is called the specific latent heat of fusion of ice. And to convert water to ice is called specific latent heat of freezing of ice. Okay, the temperature will be the same. Temperature will be 0 degrees Celsius only. Okay, the specific latent heat of fusion of ice is the heat energy which is required to melt unit mass of ice at 0 degrees Celsius to water at 0 degrees Celsius. Remember, it is a unit mass. for a given mass of a substance without any change in temperature. The temperature will remain 0 degrees Celsius. And the specific latent heat of freezing of ice is the heat energy released when a unit mass of water at 0 degrees Celsius freezes to ice at 0 degrees Celsius without any change in temperature. Understood? You have to remember, when it comes to the case of specific latent heat, the important thing is you will have to mention about the mass, about the unit mass. Without mass, it is the latent heat. Okay, when you take unit mass or a given mass of a substance, it becomes specific latent heat. Now, I'll be discussing some natural consequence of high specific heat capacity of fusion of ice. The high specific heat capacity. The specific heat capacity of fusion of ice is equal to 336,000 joule per kilogram. So, this is a very high value. Okay, so this high specific heat capacity, what is the reason? First example we are taking is the snow on mountain does not melt all at once. When you take the snow on mountain, we have said that it is in the ice state. Okay, so here we know that the ice has a high specific heat capacity, which means the heat from the sun will be used by this ice to get converted to water very slowly. Okay, if the specific heat capacity of ice, of fusion of ice is very low, then what happens? With the heat energy from the sun, it will easily get converted to water, and it may create floods in the rivers. Okay, and there will be no water anymore. So here, since the specific heat capacity of ice is very high, now what happens? The water, that is a conversion to water, won't take easily. Okay, that doesn't occur very easily. Only a small amount will be getting converted. So the ice at top of mountains do not melt completely because it requires this much, that is 336,000 joule per kilogram of heat to melt 1 kilogram of ice. If there is 1 kilogram of ice, this much of heat energy is required. The sun can provide this much of heat energy just to melt 1 kilogram. Okay, only then it gets converted to water. If this doesn't happen, that is if it is a very low value, then floods will be created in the rivers. Second, in cold countries, water in lakes and ponds does not freeze all at once. So here again, we know that the specific latent heat of ice, of fusion and of freezing of ice is 336 joule per gram or 336,000 joule per kilogram, which is a very high value. You know, when you consider the water in lakes and ponds, in order for it to get freezed, the heat energy should be liberated. So heat energy, when it liberates heat energy, it can get freezed. But here what happens is, due to this high value of specific heat capacity, it cannot, that is the water in lakes, it cannot liberate this much of heat energy to get converted to ice, okay, to get freezed. Also, for this water, there will be a layer of ice formed over it, and it doesn't escape. That this layer will prevent the escaping of heat, because this layer is a poor conductor of heat, and this layer will prevent the escape of heat from the water. Okay, only if heat energy gets escaped or heat gets liberated from water, it gets converted to ice, but it doesn't allow the escaping of heat. Okay, so due to this reason, it is very, you can say that in cold countries, water in lakes and ponds, it does not freeze very easily, or at once it doesn't get freeze. If it gets freeze, it will affect the aquatic life. That is, the life of aquatic beings will be affected. So, that is very helpful. That is, this high specific heat capacity is very helpful for the aquatic life. Their survival doesn't get affected. Drinks gets cooled more quickly by adding pieces of ice than ice cold water at 0 degrees Celsius. You have seen in case of juice and all, you will be adding ice instead of ice cold water. What is the reason? So when you use ice, if you are taking 1 gram of ice and 1 gram of ice cold water, okay, in this case, to convert the ice completely to water, 336 joules of heat energy, that is, ice is getting converted to water, heat energy should be absorbed, right? So 336 joules of heat energy will be absorbed. Here there is no conversions, no conversion is happening. Okay, so extra 336 joules of heat energy is getting absorbed, that is, the temperature of this drink will decrease. So this is the reason why 1 gram of ice can produce more cooling effect, that is, can cool the drink more easily compared to ice cold water of the same mass which is at the same temperature, 0 degrees Celsius. Both are at 0 degrees Celsius, but still the cooling that is produced by ice will be more. Fourth one, when ice in a frozen lake starts melting, its surrounding becomes very cold. So when you consider the ice in a frozen lake, so this ice should get converted to water. To get converted to water, heat energy should be absorbed. So where does this heat energy come from? The ice will start absorbing heat energy from the surrounding. When heat energy is getting absorbed from the surrounding region's temperature will decrease, okay, and this will be producing cooling effect of the surrounding, and that is the surrounding will get more cold. It becomes more cold when this heat energy is being absorbed by the ice in order to melt and get converted to water. This is the reason why the surrounding becomes cold. It is generally more cold after a hailstorm when ice melts than during or before the hailstorm. So during a hailstorm or before hailstorm, there is no change happening. But here, after a hailstorm, what happens is the ice will get converted to water. Okay. While conversion of ice to water, again what is happening? Heat energy is absorbed. Okay, heat is getting absorbed. Where does this heat come from? From the surrounding, heat energy is getting absorbed. What happens to the surrounding temperature? The temperature of surrounding will start decreasing because heat energy is getting absorbed. Due to this reason, what happens? The surrounding will become cold. This is what happens. Just you have to remember this thing. During the melting process, heat should from somewhere they should get heat. That is, from surrounding they will be taking heat in order to melt. Okay. So during this, what happens? The surrounding temperature will decrease, which means that the surrounding will become cold. That's all for today. In today's class, we have discussed the change of phase. We have discussed what melting, boiling, freezing, vaporization, condensation, solidification, sublimation, etc. are. We have studied about the boiling point, melting point, latent heat, specific latent heat of fusion, latent heat of freezing, etc. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to Learno Hub. Learno Hub free hai, par best hai. Thank you.